Welcome to Science 10 Lesson 1, Course Syllabus, Elements in a Chemical Formula, and WHMIS and MSDS. Look at the periodic table. Notice how elements can have two types of symbols, either a single capital letter or it can be a capital letter that is followed by a lowercase letter. Most countries use these symbols for the elements. This allows scientists who do not speak the same language to communicate their findings to one another. Symbols on the periodic table must be written in your notes exactly as they appear on the periodic table. Your work will be very confusing if you do not use the correct uppercase and lowercase letters. For example, if you write capital C, small o, that is called cobalt. You have one cobalt atom. But if instead of writing capital C, small o, you write capital C, capital O, that is called carbon monoxide. That means you have one carbon atom and one oxygen atom. The two are very different from one another. Cobalt is a metal, carbon monoxide is a poisonous gas. Point 2. Subscript numbers behind the elemental symbol are used to identify the number of atoms in that compound. If no number follows the symbol, only one of that element is present. Here we have C all by itself, so we have one carbon atom. Now we have H with a 4 following it, which means we have 4 hydrogen atoms. In the molecule of water, we have H2O. That's H followed by a 2, so that means we have 2 hydrogens. And then O, not preceded by a number, which means we have 1 oxygen. Point 3. Sometimes brackets are used in the formula. The subscript number following the bracket is multiplied to everything inside the bracket. I have a Cl and a Cl, giving me a total of 2 chlorines. I have a C, which gives me 1 carbon atom. It is inside brackets, so I have to multiply it by 4, giving me a total of 4 carbon atoms. H, there's 2 of them. It is also inside of brackets, so I have to multiply it by the 4, giving me a total of 8 hydrogen atoms. Ca, there's 1 Ca, and I know the C goes with the A because the A is a lowercase, so it belongs to the C that preceded it. And there's only one of them, so I have 1 calcium atom. I also have 1 manganese, but it is inside of brackets, so I will have to multiply it by 2, giving me a total of 2 manganese atoms. I have 4 oxygens, also inside of brackets, so I will have to multiply that by 2, giving me a total of 8 oxygen atoms. Point 4. If a number precedes a chemical formula, then there is more than one of that formula present. In this case, the number that precedes the formula is multiplied by everything in the chemical formula. If I have barium fluoride, I have 1 barium atom and 2 fluorine atoms. If I placed a 2 in front of the BAF2, that means I have 2 barium fluorides and everything must double. So 1 barium atom becomes 2 barium atoms, and 2 fluorine atoms becomes 4 fluorine atoms. In calcium permanganate, I have 1 calcium atom, 2 manganese atoms, and 8 oxygen atoms. If I placed a 3 in front of there, that would give me 3 calcium permanganate crystals. So that means 1 calcium atom would become 3, 2 manganese atoms would become 6, and 8 oxygen atoms would become 8 multiplied by 3 would give me 24 oxygen atoms. Our examples. This is the way I want you to complete the assignment. First, we'll write down what elements are present in the formula. I have P, and I have Cl. I know the C and L are together because the L is lowercase and it cannot be by itself, so it belongs to the C. So P, there's 2 of them, so I have 2 P's. Cl's, there's 10 of them, so I have 10 Cl's. In sodium sulfate, I find Na, I find S, and I know the S is not with the O because the O is uppercase, so they cannot be together. So S, and I also have O. Na, there's 2 of them. S is not followed by a number, so there is only 1 sulfur. And O, there are 4 oxygen. Let's start by writing out the elements that are present. We will start with cobalt-3 carbonate. I have CO, and I know the C and O are together because the O is lowercase and it belongs to the C. I also have C by itself and an O by itself. CO, there are 2 of them, so I have 2 cobalt atoms. Carbon, there's just 1 of them. It's inside brackets, so I will have to multiply that by 3, giving me a total of 3 carbon atoms. Oxygen, there are 3 of them. It is also inside of brackets, so I will have to multiply it by 3, giving me a total of 9 oxygen atoms. Now let's look at lead-4 sulfate. I have Pb. I know they go together because the B is lowercase. I have S all by itself, and I have a capital O which goes all by itself. Pb, there is just 1 of them, so I have 1 lead atom. Sulfur, there is just 1 of them, but it is inside of brackets, so I must multiply it by the 2, giving me a total of 2 sulfur atoms. Oxygen, there are 4 of them. It is also inside of brackets, so I will have to multiply it by the 2, and that gives me a total of 8 oxygen atoms. Final set of examples. We'll start with ammonium iodide. First, again, we will write out the elements that are present. We have capital N, capital H, and capital I. Nitrogen, there's just 1 N, and I will have to multiply it by the number that precedes the formula, which is a 2, giving me a total of 2 nitrogen atoms. Hydrogen, there are 4 hydrogens. I will have to multiply that by the 2 that precedes the formula, so I have a total of 8 hydrogen atoms. Iodine, I have just 1, and again I will multiply by the number that precedes the formula, and that gives me a total of 2 iodine atoms. Now let's look at strontium acetate. I have Sr. I have a capital C. I have a capital H. I have a capital C, but I will not rewrite capital C because it's already in my list of atoms. I have a capital O, and I have another capital O, so again, I will not rewrite that O, for it is already in my list. Sr, there's just 1, and I will have to multiply it by the 3 that precedes the formula, giving me a total of 3 strontium atoms. C, I have 1 here and 1 here. That's a total of 2 carbons. I will have to multiply it by 2 because it is inside of the brackets. and then I will multiply by the 3 that preceded the formula. And that gives me a total of 12 carbon atoms. Hydrogen, I have 3 inside of brackets, so I'll have to multiply by 2. And then I will have to multiply by the number that precedes the formula, which is 3, giving me a total of 18 hydrogen atoms. Finally, I have an O and an O, which is a total of 2 O's. They are inside the bracket, so they must be multiplied by the 2. And then I will multiply by the 3 that precedes the formula, giving me a total of 12 oxygen atoms. Introduction to chemistry. What is chemistry? Chemistry is the study of matter, its properties, and its changes or transformations. Matter is anything that has mass, takes up space, and has physical and chemical properties. WHMIS. WHMIS is a comprehensive plan for providing information on the safe use of hazardous materials used in Canadian workplaces. WHMIS was covered in grade 9 and will be revisited in this course. Together, let's fill in the following information. What does the acronym WHMIS represent? WHMIS stands for Workplace Hazardous Materials Information System. Compressed gas. Normally a gas placed under pressure or chilled and contained by a cylinder. Considered to be dangerous because they are under pressure. If broken, the cylinder can rocket or torpedo at great speeds. If heated, the cylinder may explode. If leaking, the cylinder may cause frostbite. Air leaving the cylinder can be very cold. Flammable material. This class covers materials that can ignite or catch fire easily. The main hazards are fire or explosion. Oxidizing. These materials can produce oxygen given the right conditions, or are comprised of oxygen and could possibly intensify a fire, cause a fire, or create an explosion. Corrosive. Mostly acids or bases. Corrosive materials can attack and chemically destroy exposed body tissues. They can also damage or even destroy metal. Explosion hazard. Products with this pictogram present severe fire and explosion hazards. Significant injury and property damage could result from incidents involving these products. Harmful or fatal. Can cause death or toxicity with short exposure to small amounts. Extremely harmful even with a limited exposure. Health hazard. These materials can cause a health effect, such as eye irritation, respiratory sensitization, may cause allergy or asthma symptoms or breathing difficulty if inhaled, or carcinogenicity, may cause cancer. Harmful. These materials can cause eye irritation, skin sensitivity, cause respiratory damage, but to a lesser extent to those labeled as a health hazard. They may also cause toxicity to specific organs even after a single exposure. Biohazard, infectious. This includes all bodily fluids of all living materials, as well as any organism that has been shown to cause disease or to be a probable cause of disease in people or animals. Harmful to the environment. These materials, if not properly disposed of, can pose long-term hazards for aquatic life forms. This is in the form of bioaccumulation, which is how much the organism absorbs. We were told growing up in Prince Albert that you are not supposed to eat fish from the North Saskatchewan River too often, especially older fish, because the longer the fish was alive in the river, the more mercury that it would have accumulated. And then that mercury, when you eat the fish, would accumulate inside of your body. The second part of that is degradation, which means how long it remains in the organism. If it is a toxin, that is absorbed and easily shed, it's not as harmful to the environment as a toxin that is ingested by the animal but stays in the animal until it dies. MSDS. What does the acronym stand for? Material Safety Data Sheet. Your handout is in black and white. I want you to make a note that the top triangle is red, that the one on the left is blue, and the one on the right is yellow. Please make that note on your sheet. Manufacturers and suppliers of chemicals are required to provide material safety data sheets. They contain a list of hazards, including fire and explosion, physical and chemical characteristics, information on the effects of exposure, treatment due to exposure, recommendations for safe handling, first aid procedures, and how spills are to be cleaned up. And that brings us to the end of this lesson.